Hi everyone, my name is Ben Lafreniere, and I'll be presenting our paper investigating aggregated versus sequential command recommendation in graphical user interfaces. And this was a project at Reality Labs Research with the co-authors that you see here. So just as a brief intro, command recommendation is a type of AI assistance where a system predicts what the user is going to do next and then recommends commands based on that. And if the prediction is correct, the user can proceed with their task just by accepting the system's recommendations. Early work in the space looked at predicting and recommending individual commands, but subsequently there's been work developing methods for predicting multi-command sequences or entire workflows that a user might want to do next. And this raises a really interesting question. What is the best approach for presenting multi-command recommendations to a user? Is it better to take a sequential approach, where the commands are recommended one at a time, or an aggregated approach, where the commands are recommended all together, allowing the user to accept or dismiss them as a group? And this question is the focus of this paper. So specifically, we set out to answer the following research questions. First, how does task performance change with an aggregated versus a sequential approach? Second, how does use of command recommendations over a static menu change with the aggregated versus the sequential approach? And finally, what user behaviors characterize use of aggregated recommendations? So to investigate these questions, we developed a study system in task, which I'll show, and we propose a novel aggregated recommender interface design with a sequential equivalent. And then we conducted 2 online studies to investigate these 2 approaches for different levels of recommendation quality. So I'll start by introducing the study system and task that we developed. So here's the overall interface for the study system. Goal image is presented on the right, and the user has to recreate it on the left. And to do so, they can use a static hierarchical menu, and depending on the condition, shortcut recommendations. So here's a demonstration of the user completing a couple of trials using the static menu only. They set the outline, set the thickness. Here's another trial. They select the shape. I set the fill and the thickness. So next I'll show the 2 recommender interfaces. So here's an example aggregated recommendation with 3 commands in it. Clicking accept would perform all of the commands, and dismiss would dismiss them. And here's a demo that shows the aggregated interface in action. So here the user adds a command to the recommendation, and then accepts it. Here we've got 4 commands, and the user is editing one of the commands, and then removing another one for accepting it. And then this final example shows that even in the conditions with recommendations, the user could still use the static menu as well. Okay, and now here's the sequential interface equivalent, which is sort of a simplified version of the aggregated interface, where you get the commands one at a time. So it's here, they get a shape command. They change it and accept it. They get one that they dismiss, another that they accept, another that they accept. So we designed the study task so that we could manipulate the utility of recommendations, which we define as the number of clicks that can be saved by using an aggregated recommendation over the static menu. So for the trial that you see on the slide here, it would take 10 clicks in the static menu to recreate the image. A perfect recommendation has utility 9. Since it can save 9 clicks of the static menu, you still have to click accept. And then there's here's another example of an imperfect recommendation, which has utility 6, because there's a missing command that would take 3 clicks to add, plus the accept click. That's 4, 10 minus 4, 6 utility. So we generated trials by producing a perfect recommendation and then adding errors to it to get to the desired utility. And you can see the paper for full details. I won't go through all the details for our study method. You can check the paper for that. But we used a fully between subjects design with 3 interface conditions, aggregated, sequential, and static menu only, crossed with 3 target utility distributions for the conditions that had recommendations. Okay, so what did we find? Well, here's a graph of results for performance in terms of number of clicks to complete trials. And so we can see that it looks like the recommender conditions are performing well, and they're performing better as the utility of recommendations goes up, which we would expect. And ANOVA showed significant differences between the interfaces, with the aggregated and sequential outperforming static menu only, and the aggregated outperforming the sequential. And analysis of covariance showed that the difference between the 2 recommender conditions was driven by differences in the high utility condition. So when we look at performance in terms of trial time rather than number of clicks, the results are a lot less definitive. Here we do not see a significant main effect between the interface conditions, and we can also see that the static menu only condition users performed quite well, and that's likely because users are very well practiced at using static menus. To look at our second research question about use of recommendations versus the static menu, we examined the proportion of actions completed through the static menu versus the recommender interfaces. And what we found is that most actions are completed through the recommender interface in the aggregated condition, but this flips for the sequential condition. So this is kind of a cool result because it suggests that the aggregated approach encourages greater engagement with the recommender interface to complete tasks. Finally, we conducted an analysis to test whether the aggregated interface shows benefit for planning actions. So here we're graphing the average, what we call deliberation time before clicking edit on individual commands and recommendations. The timeline diagram gives a sense of how we computed this, but you can check the paper for details. But what I want you to notice is that for the aggregated condition, the blue bars, the deliberation time drops as we go from the first to the second to the third command. So this suggests that the aggregated interface is enabling the user to kind of plan ahead the edit actions that they want to perform. Whereas in the sequential case, it stays high for each new command. And this was confirmed with a regression analysis, which you can find in the paper. So in summary, we found that aggregated command recommendation reduced the number of interface actions to complete tasks. It increased engagement with the recommender interface over the fallback static menu, and it enabled anticipatory planning of corrections to recommendation errors. But we didn't see a clear result for performance time. And this got us kind of curious. What if we really leaned into the anticipatory planning advantage by making it even easier to assess sets of recommendations? And so that led us to study 2. Stating what I just said more clearly, our hypothesis was that a visual preview of the effects of recommended commands would further reduce the cognitive effort to assess aggregated recommendations, resulting in improved performance. To test this, we modified the aggregated interface so it starts with a visual preview that you can see here. See another example in a second. Yeah, you have this visual preview, but clicking edit expands it out to something very similar to the aggregated interface from study 1, except it has this updating visual preview in the top right. And you can see that again here. All right. And we added an equivalent preview for the sequential interface, which you can see here. We'll see one more example in a second. Yeah. Okay. So the study 2 method was similar to that of study 1 with a couple of very small differences. We made the goal images a bit more complex, and we also didn't include a static menu only condition because our focus was really on testing this hypothesis between the 2 recommendation interface types. Okay, on to results. So similar to before, for number of clicks, we see that aggregated outperforms sequential. But unlike study 1, where we only saw a significant difference for the high utility condition, now we see it for both high and medium utility, which lends some support to our hypothesis. For trial time, we still don't see a significant difference, but the result is kind of right on the margin with p equal 0.054. To take a closer look, we examined the data in terms of the utility of recommendations for individual trials. So here we're graphing the time to complete trials on the y-axis by the per trial recommendation utility on the x-axis. So at the far right, you have utility 12, which was perfect recommendations for this study. And so what we see is aggregated is about performing about the same as sequential when recommendations are lower utility, but then we see this divergence for high utility recommendations of utility 8 or higher. And so what this suggests is that a benefit of the aggregated approach comes from enabling the user to rapidly recognize and take advantage of high quality recommendations. And the difference here is actually quite significant. In the perfect case, you have about 19 seconds for sequential versus only 8 seconds for a trial in the aggregated case. Okay, I just want to end with some key takeaways. First, aggregated command recommendation has advantages. We see a performance benefit, especially with a well-designed preview mechanism, and that it promotes greater use of the recommender interface over a fallback static menu. We also show that these advantages come from supporting certain user behaviors, like efficient assessment and correction of sets of commands and rapid recognition of high utility recommendations. With that, I'll end, and I'd be happy to take questions. Thank you for watching.